Welcome to my lecture. Myself T. Muthukumar, Assistant Professor, Bangalore College of Engineering and Technology. So today, I'm going to deliver a lecture on Maxwell equations in electromagnetic fields. So this is very important topic in electromagnetic fields. So Maxwell derives 4 equations. So we are going to discuss one by one. So these 4 equations is derived from 4 different laws. So Maxwell equation number 1. So this is derived from the Ampere circuit law. So for steady state magnetic field, the Ampere circuit law states that so del cross H is equal to J. J is called current density. So del cross H is equal to J. But it is inadequate for time varying conditions. So taking divergence of equation. So we are taking the divergence on both sides. So del cross H is equal to del dot J is equal to 0. So this is the divergence. Del cross H is equal to del dot J is equal to 0 because the divergence of curl is identically 0. However, the equation of continuity is del dot J is equal to minus dou rho v by dou t. So this is the continuity equation. Del dot J is equal to minus dou rho v by dou t. So this value to be 0 to satisfy the Ampere circuit law, but it is unrealistic. So amending Ampere circuit law for time varying fields. So we are going to write Ampere circuit law for time varying fields. So del cross H is equal to J plus JD. So J is called conduction current density, JD is called displacement current density. So taking divergence on both sides, so del cross H is equal to del dot J plus del dot JD. So del cross H value is equal to 0 for identity value 0. So that's equal to del dot J. So we already know the continuity equation. Del dot J is equal to minus dou rho v by dou t plus. So we are going to write so del dot JD. So from this equation, so del dot JD value is equal to continuity equation, that is the rho dou v by dou t. So first we are going to take del cross H equal to J. So that this is the steady state magnetic field condition. So taking divergence on both sides, del cross H is equal to del dot J, that's equal to 0. So del dot J value is equal to 0 because the divergence of curve is identically 0. And also continuity equation, del dot J is equal to minus rho v by dou t. So from the time varying magnetic field, del cross H is equal to J plus JD, taking divergence on both sides. So finally we get del dot JD value is equal to dou into rho v by dou t. So replacing rho v by del dot D. So because we have the formula from the Gauss law, del dot D is equal to so rho v volume charge density is equal to divergence of electric flux density from the Gauss law. So del dot J is replaced by del dot dou D by dou t. So from this equation we are going to calculate JD value. So JD value is equal to dou D by dou t. So D is called flux density. So dou D by dou t is called displacement current density. So dou D by dou t is equal to displacement current density. J is called conduction current density. JD is called displacement current density. So now we are going to apply this value to the basic Ampere circuit law. So del cross H is equal to J plus JD. So JD value is equal to dou D by dou t. So the equation becomes del cross H equal to J plus dou D by dou t. So this is the Maxwell equation 1 from point form or differential form. So this is the Maxwell equation 1. So del cross H equal to J plus dou D by dou t. So to obtain the integral form, so we are going to use apply the Stokes theorem. Okay, to obtain the integral of Maxwell first equation, taking surface integral on both sides. So for the equation number 4, So surface integral del cross H ds is equal to surface integral dou d by dou t into ds plus surface integral j ds. So we are going to take commonly dou d by dou t plus j into surface integral ds. So this is called the Maxwell equation number 1. So line integral of h dot dl is equal to surface integral. This is the Stokes theorem. So with the help of the Stokes theorem, so we are going to write line integral of h dot dl is equal to surface integral of j plus dou d by dou t. So this is the Maxwell equation number 1. So del cross h is equal to j plus dou d by dou t is called differential form or point form. So this is integral form. Line integral h dot dl is equal to surface integral j plus dou d by dou t. So this is Maxwell equation number 1. So next we are going to discuss Maxwell equation number 2. So Maxwell equation number 2 is derived from the Faraday's law of electromagnetic induction. So EMF can be represented by line integral of electric field around a closed path. So EMF is equal to line integral of E dot dl. So total flux passing through the circuit is equal to the integral of normal component of the flux density over the surface bounded by the circuit. So from this concept, flux density phi is equal to magnetic flux phi is equal to surface integral b dot ds. So surface integral b dot ds. So from Faraday's law, so we are going to write EMF induced is equal to rate of change of flux. So minus d phi by dt. So EMF is equal to minus d phi by dt. So we are going to equate both EMF equations. So E dot dl is equal to minus d phi by dt. So based on the electric field intensity, EMF is equal to integral E dot dl. Based on magnetic field intensity, so EMF is equal to minus d phi by dt. So substitute flux value in equation 7 from equation number 6. So from this equation, we are going to substitute this flux value. That is the integral surface integral b dot ds. So equation becomes minus d by dt. So apply this flux value here. So integral b dot ds. So line integral of e dot dl is equal to minus d by dt into surface integral of b dot ds. Next equation becomes line integral e dot dl is equal to minus surface integral dou b by dou t into ds. So dou b by dou t into ds. So we are going to write d by dt as here dou b by dou t. So dou b by dou t into ds. So this is the integral form of Maxwell equation number 2. It is also called transformer induction equation. So integral line integral of E dot dl is equal to minus surface integral dou b by dou t into ds. So if you want to determine the point form, so we are going for the Stokes theorem. To apply Stokes theorem, so surface integral del cross E into ds is equal to minus dou b by dou t into ds. So Stokes theorem is integral E dot dl is equal to surface integral, that is single integral. It is used to convert line integral into surface integral into del cross E into ds. We are going to equate this del cross surface integral del cross E into ds is equal to minus surface integral dou b by dou t into ds. So neglecting the integration and differentiation terms, so finally we get del cross E is equal to minus dou b by dou t. So this is the Maxwell equation 2. So this is derived from the Ampere's. This is derived from the Faraday's law of electromagnetic induction. The statement is electromagnetic force, motive force around a closed path is equal to the negative of the integral of the time rate of magnetic flux density over the surface bounded the closed path. That is the meaning is the negative rate of change of magnetic flux density over the surface bounded by the closed path. So this is the Maxwell equation derived from the electric Gauss law. So electric Gauss law is equal to surface integral d dot ds is equal to q. So similarly, q is equal to volume integral rho v into dv. So equating these two equations, so we are getting surface integral d dot ds is equal to volume integral rho v dv. So surface integral d dot ds is equal to volume integral rho v dv. So this is called the Maxwell's equation number 3. So this is in the integral form. So if you want to calculate the differential form, so we are going to apply the divergence theorem. So volume integral del dot d dv is equal to volume integral rho v into dv. So removing the differentiation and integration terms, so finally we get del dot d is equal to rho v. So this is the point form of Maxwell equation 3. So del dot d is equal to rho v. So del dot d point form of Maxwell equation, del dot d is equal to rho v. So statement: the total electric flux passing through any closed surface is equal to the total charge enclosed by the surface. Total flux passing through any closed surface is equal to total charge enclosed by the surface. So last one is Maxwell equation number 4. So Maxwell equation number 4 is derived from the magnetic Gauss law. So Gauss law for magnetic field, surface integral b dot ds is equal to 0. So if you want to take this is the integral form. So if you want to derive the differential form, means need to apply the divergence theorem. So after applying the divergence theorem, del dot d value is equal to 0. So this statement is the net magnetic flux emerging in a closed surface is equal to 0. Net magnetic flux emerging in a closed surface is equal to 0. So 4 Maxwell equations derived from 4 the fundamental magnetic laws. We are going to do the summary. So Maxwell equation 1 is derived from the Ampere's electrical law. So this is derived from the Ampere's law. So Maxwell equation is derived from the Faraday's law. So it is derived from the Faraday's law. Maxwell equation 3 is derived from the electric Gauss law. So electric Gauss law. It is derived from the electric Gauss law. And equation number 4 derived by magnetic Gauss law. So integral form of Maxwell equation 1, sin integral of s dot dl is equal to surface integral of j plus dou d by dou t into ds. So if you apply the Stokes theorem, we are getting the differential form del cross h equal to j plus dou d by dou t. So integral e dot dl, Maxwell equation 2 equal to integral e dot dl is equal to minus surface integral dou b by dou t into ds. So del cross e is equal to minus dou b by dou t. This is the differential form. So by applying the electric Gauss law, surface integral d dot ds is equal to volume integral rho v dv. So differential form is del dot d is equal to rho v. So Maxwell equation 4 is derived from the Gauss law for magnetic field. So integral b dot ds is equal to 0. So if you take the divergence theorem, if you apply the divergence theorem, del dot b is equal to 0. So this is the 4 fundamental Maxwell equations. So 4 equations is derived from the different magnetic laws. Thank you.